In this video, we're going to take a look at a new kind of angle with circles. These are called inscribed angles. So to define them, an inscribed angle, it's an angle that has its vertex on the circle and its sides are going to be chords of that circle. So looking at this picture here, angle DEF has its vertex E on the circle, and ED, EF, those are both chords. So therefore, DEF would be an inscribed angle. We are going to see how do these relate to angles we've already worked with and arcs in a circle. So to do that, we want to focus on that arc DF. We call that what is referred to as an intercepted arc. So that's any arc contained either by a central angle or an inscribed angle. So that arc DF, that's sort of contained inside of my angle DEF. And if I was to make central angle DGF, it would also be contained inside of that angle. So how do these things relate to each other? Well, it turns out we have a theorem, and we can prove this using a bunch of triangles. It says that any inscribed angle is always going to be half of the intercepted arc. So that's how their measures relate to each other. So looking at that diagram, angle DEF has a measure that's always half the measure of arc DF, which is also the same as half the measure of angle DGF. So for example, if arc DF was 100 degrees, then angle DEF would be 50. And conversely, let's suppose that angle DEF was 60. Then arc DF would have to be 120 degrees. So it's a nice, quick way to get from one measure to the other. Now let's suppose that we have two inscribed angles and they intercept the same arc. They will have to be congruent. So using that same picture there, looking at arc DF, angle DEF is always 1/2 of arc DF. But then if angle DRF also has that same intercepted arc DF, it's also going to be half of whatever arc DF is. So angle DEF has to be the same, or it has to be congruent to angle DRF. They have to have the same measurement because each of them is half of the same measurement. So that could go for any number of inscribed angles. I could put another point somewhere between E and D on that circular arc and connect it to D and then connect it to F. That would have the same intercepted arc. I could do that all around that circle as long as I'm not on arc DF, and I'd always be half of DF, which gives me the same number. So that's going to be really useful to us. We have a follow-up to that. If I have a diameter, so if I have a diameter and then I connect the endpoints to some part of my circle, I make a new inscribed angle like this one here. So AC is the diameter. That tells me that angle ABC has to be a right angle. So you might wonder, well, why is that? Well, if you look at that red arc from A over to C, that is a semicircle. Semicircles have a measurement of 180 degrees. Since angle ABC has that arc intercepted, it's going to be exactly 1/2 of that. Half of 180 is 90. So this will be another useful one where we might have to refer to SOHCAHTOA or 30, 60, 90 triangles or 45, 45, 90. All of those chapter 8 right triangles might pop up with questions like this since we will be working with right triangles. The last thing in this section has to do with quadrilaterals. So if you have an inscribed quadrilateral, remember that means all of its vertices are on the circle and all of its sides are going to be chords. That means that all of the opposite angles will always be supplementary. So for example, here I have circle R and quadrilateral ABCD is inscribed in that circle. This is telling me that angle A is always going to be supplementary to angle C, and also angle D is always supplementary to angle B. So you might wonder, why is that? Well, let's take a look at that green arc, BAD. Now, whatever that measurement is, we know angle C is always 1/2 of that measurement because it's an inscribed angle, and inscribed angles are always half of the intercepted arcs. What if we look at the remaining portion of our circle here in red? So that arc from B through C to D is the intercepted arc of angle A. whatever angle A is, it's always going to be 1/2 of that intercepted arc. Now, if you add together both the green and the red arcs, that's a full circle. So the rotation would be 360. Taking half of those, since each of those inscribed angles, A and C, are half of each of their respective intercepted arcs, half of the sum, 360, would be 180. So that just means if you add the measures of A and C, you're always going to get 180. And the same is going to be true for B and D. So that should do it for 10.4.